Assalamu alaikum everyone, welcome to the part 2 of the May June 2019 paper 1-2 lesson. So here we are with episode 2 for the study with me O-level chemistry. So right now we are basically doing the past paper coverage. As I solve this paper, if you find this helpful, give it a thumbs up, and if you want me to do any specific questions, do leave it down in the comments below and I'll make sure to do them. Okay, let's begin with the question number 21. Why is ethanoic acid described as a weak acid? Now remember, the only way that we differentiate a strong acid from a weak acid is by the extent to which they ionize in aqueous solution. We say strong acid ionizes completely in aqueous solution, and we say that a weak acid ionizes partially in aqueous solution. That's actually the only way that we differentiate the two. So let's look at the options. 21A, it is an organic acid. Well, yes, it's true that organic acids are weak acids, but can I actually define a weak acid as being weak because it's an organic acid? That doesn't sound like the right way to define a weak acid. So I wouldn't actually go for option A. B, it is a poor conductor of electricity. That's actually a good one. It's true, it's definitely true, but again, I wouldn't actually justify a weak acid as being weak because it's a poor conductor of electricity. But I'll keep that one on hold. See, it only slightly dissociates in water. Exactly. As I said, that's the true definition. That's actually how we differentiate a strong acid and a weak acid. Even in the exam in paper 2, there will be a repetition of what is a strong acid, what is a weak acid, and you will find only these being one of the answers. Either it's this or it's this. It's either of these. But one thing is true, let me mention that. There is a cause and effect relationship. Because a weak acid dissociates, it dissociates partially, so there are very few ions in the aqueous solution. Therefore, there are less mobile ions, and therefore there is a poor conduction of electricity. But as I said, we are talking about defining a weak acid here. So B can't be the answer, but there's definitely a cause and effect relationship. It reacts with only very reactive metals. Now that actually doesn't even make sense. Why? Because if something is an acid, regardless whether it's strong or weak, it will react with both metals and bases. But one thing is true. Strong acids will react more vigorously with metals and bases, and weak acids will react more slowly and less vigorously. Okay, but I can't really categorize that these are the very reactive metals with only which a weak acid would react. That's wrong. So guys, the answer is C. I hope this made sense. I don't know if I should mention something here. I just want to, so I'll just do it. Ethanoic acid, there's a very famous name for ethanoic acid, and that is acetic acid. Acetic acid. Remember that. Why I want you to remember that? Well, because I think in the future it might not appear in O levels, but if you go up and if maybe you do give the MCAT or you try to study Episode or whatnot, you would actually require this term. It's kind of famous, so I think it's a nice way to memorize things beforehand. Always think in the long run. Okay. Second question. What is the best method to prepare a sample of silver chloride? The only place in the syllabus where you have actually prepared a sample of silver chloride is when you did a test for the chloride ion. What you did was you had this Ag plus ion. I'm writing down the ionic equation here, which was aqueous. Then you reacted it with the chloride ion, which was also aqueous, and you got AgCl, which was a solid, and it basically gave us white precipitates. So the only place in the syllabus you see AgCl being formed and you have to memorize this ionic equation is when we are testing for the chloride ion. Note how we require Ag plus ion in aqueous form and chloride ion in aqueous form. So this means we need to have these have aqueous solutions of their soluble salts. Why soluble? Because if they will be soluble, only then they can go in water and dissociate. A. Add silver nitrate to chlorine. As I said, there's no mention of aqueous here, so A can't be the answer. And by the way, silver nitrate is a solid at room temperature. Its melting point is about 210 degrees Celsius, and chlorine is a gas. I don't see how they can actually possibly react here. B. Add silver to hydrochloric acid. Wrong. Why? Because if you remember the reactivity series, there's potassium and then there's a long run and then you see hydrogen and then there's a long run and then you see Ag. We know that in the reactivity series down the group the reactivity decreases, right? And there's something to remember, and that is more reactive metals can displace less reactive metals. I hope your teacher told you this while you were doing the chapter of metals, that only more reactive metals can displace less reactive metals. Now, because silver comes below hydrogen in the reactivity series, it can't really displace hydrogen in its, when it's in a compound. Over here, they're actually asking us to do this because there's silver and then there's HCl. This is a compound in which hydrogen is a part of. So Ag can't actually displace hydrogen in this compound and form AgCl because it is less reactive. So C can't be the answer. D, mix aqueous solutions. Oh, sorry, B can't be the answer. And C, well, again, as I said, silver is a solid, chlorine is a gas. There isn't actually a reaction between the both when you burn silver and chlorine. As I said, these questions are never out of syllabus. There's always something in the syllabus that will provide you with the answer. And as I said, that's the ionic equation. You should have memorized it. You should have noted that the Ag plus and the chloride ion are both aqueous. That's the only way they can react to form AgCl. So the answer is D. Okay, sodium chloride is soluble. Sodium chloride is soluble. It's ionic. It's soluble. It gives us Na plus ions and chloride ions in aqueous form. Silver nitrate, all nitrate compounds are soluble. So you get Ag plus and you get nitrate ion. So you have all these four ions in aqueous form. So Ag aqueous and chloride aqueous react through this ionic equation and give us AgCl. Okay, going on. The nitrogenous fertilizer urea, this is urea, has the structure shown. Which percentage by mass of nitrogen does it contain? So we're talking about nitrogen and we're interested in the percentage by mass in this compound. Remember, for percentage by mass questions, the formula that I can say, in a way it's a formula that you should memorize is that percentage by mass is equal to AR of the element in which you're interested in. Over here it's nitrogen, into the number of atoms of that element in that compound divided by MR of the compound, and multiply that by 100 to make it a percentage. Let's apply it here. Nitrogen is 14. There are 2 atoms of nitrogen in urea. MR will be 14 into 2 plus we have 4 hydrogen, so 4, and then we have 1 carbon, so that's 12, and we have 1 oxygen, so that's 16. Multiply that by 100, I get 46.6%. So this makes D correct because the closest is D. Okay, so I hope you understood this. Just memorize this formula. This will be the lifesaver in all of these percentage by mass questions, no matter what the compound is, no matter what the element is. Moving on. Ammonia is manufactured by the Haber process. Let's first look at the, वैसे ये जो आपका reaction है आपको हिफ्ज़ होना चाहिए. It's a very important reaction, and you can see that the forward reaction is exothermic in nature. Exo. Okay. Before I begin looking at the options, just a few things about the Haber process. There is a pressure of 200 atm. And why do we use such a high pressure? Because we know that high pressure favors the side of less gaseous moles. So over here I have 4 gaseous moles, over here I have 2 gaseous moles. So it's a 4:2, right? So if I have high pressure, the position of the equilibrium will shift towards the right, more ammonia will be formed, we will get a good yield. Okay, rubbing this off. Now let's talk about the temperature. So the temperature we set is 450 degrees Celsius, and there's a very famous name given to this temperature. We call this as the compromised temperature or the moderate temperature. Why? Because look, the forward reaction is exothermic. We are interested in increasing the concentration of ammonia in the equilibrium so that we get a good yield, because that it's ammonia which we are interested in. Because the forward reaction is exothermic, so technically a low temperature will favor the forward reaction. However, when we keep a low temperature, the rate of the reaction decreases, and therefore there's a very slow reaction happening, and time is money, and time is actually very important in industrial reactions. You can't sit all day just to wait for a small amount of ammonia getting produced. But at the same time, when we increase the temperature to a lot, then we see a good rate perhaps, but not a good yield, as I said, because the forward reaction is exothermic and only low temperatures favor it. So what we do is, the industrialists, they settle down at 450 degrees Celsius, because 450 degrees Celsius not only provides a good yield, but it also provides a good rate. Okay. And the third thing to know here is that the catalyst is iron. 3 very important things about the Haber process. Now let's look at the options. Nitrogen and hydrogen are mixed in the ratio 1:3 by volume. Are they? Well, they are. Look, 1:3. So they are perhaps mixed in a ratio of 1:3. The reason is the formula for ammonia is NH3. Well, isn't it true that I need 1 nitrogen and then 3 hydrogen to form 1 mole of ammonia, because it is NH3, right? But even if it doesn't make sense right now, it's okay, because I can understand this. There would be, for a student, some sort of confusion for one. Let's look at 2. The pressure used is 200 atmospheres. Yes, a high pressure is needed to produce a good yield of ammonia at equilibrium. Now that's true. The reason why we use 200 atm is that we will get a good yield of ammonia at equilibrium. So 2 is right. 3. The temperature used is approximately 450 degrees Celsius. True. A high temperature is needed to produce a good yield of ammonia at equilibrium. Wrong. Because as I said, the forward reaction is exothermic. Only a low temperature will give a good yield of ammonia. So we don't use 450 because it will give us a good yield of ammonia, but because it will give us a good rate. It's a compromised temperature. So 3 is wrong. 4. Wrong. The catalyst is iron. So that is straight up wrong. And let's explore the options. So it can only be 1 and 2, because 2 alone is no answer. So you don't really have to put a lot of thought into 1, but as I said, 1 does make sense, because nitrogen and hydrogen, why would the molar ratios actually be 1:3 at the end of the day? Because ammonia is NH3. The formula of ammonia is NH3. Moving on. Which uses for sulfuric acid are correct? As a bleach, well, it's actually sulfur dioxide, not sulfuric acid, which is used for this purpose. As a food preservative, 2 wrong. It's again sulfur dioxide, not sulfuric acid. As a raw material in the manufacture of detergents, true. As a fertilizer, well, sulfuric acid is not used as a fertilizer. However, it can be used to make a fertilizer. So 4 is wrong. The answer is D. I'll mention the uses for sulfuric acid here. These are the ones that you need to know. Sulfuric acid is used to make dyes, first of all. Secondly, it is used in the production of fertilizers. And just to give some additional information, it's actually H2SO4. No, this is actually not a good color, but H2SO4, sulfuric acid is actually used to make phosphoric acid, and then this phosphoric acid is used to make phosphate fertilizers. So if you were wondering how do we use sulfuric acid to make fertilizers, this is how. Other than that, it is used in the production of detergents. So used in the production of detergents, and other than that, the last thing is that it is used as an electrolyte in car batteries. Okay, so to make detergents and as an electrolyte in car batteries. Okay, so there you go. The answer would be D. Let's move on. Question number 26. The atomic number of element X is 12. Okay, do you know what comes at 12? It's actually magnesium. Okay, what is the formula of the chloride? I think the easiest way to solve these questions in which they say there's an element X and it has the atomic number blah blah blah, just look at the periodic table and choose, actually look for the one that has the proton number as 12. So that's magnesium here. Do you know what the chloride of magnesium looks like? It's MgCl2. So the answer is C. Okay, let's move on. This was really super easy, right? Okay, question number 27. Which property is common to calcium, potassium, and sodium? As I said, there's some sort of a prep that I always like to do in these questions. Sodium is 11, calcium is 20, and potassium is 19. It says the atoms all have more neutrons than protons. The neutron here is 20, over here it's 20, over here it is 12. So neutron more, neutron more, neutron more. So it says their atoms all have more neutrons than protons. Yeah, that's, oh no, that's not right, because they're saying the atoms have more it even tricked me for a second, more neutrons than protons. If you look at calcium, there are equal number of neutrons and protons, not more neutrons and protons. See, that's how they trick you. A is wrong. Going on to B, the ions all have 8 electrons in their outer shell. Do they? This is calcium is 20. It will actually lose 2 electrons in its valence shell, and calcium will form 2 plus, and the configuration will be 2 8 8, because 18 electrons will be left. Potassium gives us K plus, again it will have 18 electrons, so it's 2 8 8, and sodium will form plus, sodium plus, and that makes it 2 8. So all of them have, their ions all have 8 electrons in their outer shell. Do they? They do. So B is right. C, they all sink when added to water. This property is actually not true for group 1 metals. Group 1 metals actually have a low density, and in fact lithium, sodium, and potassium float on water, they don't sink. So C is not true for all three. D, they are all deposited at the positive electrode. Now tell me, if something is, this is a positive electrode and there's sodium which itself is positively charged, will positive attract? No, they will repel, because like charges repel. So this even in the world of physics gets wrong, but in the world of chemistry, well, what is a positive electrode called? It's an anode. Anions are attracted there. So not cations. So D is wrong. So the answer is B. Moving on. Which statement about transition elements is correct? Their soluble salts form colored aqueous solutions. Absolutely correct. We know that transition elements do have these colored ions and compounds, and aqueous solution that do give colored solution. So A is correct. B, they are all in the same group of the periodic table. No, you know, if you look at the periodic table, we actually talk about these as the transition elements, and we call this, let me make it correctly. Now, this right here is called a group. जिसको हम U1 और फिर 2 और फिर so on and so forth mention करते हैं. So they're not in the same group of the periodic table. They are non-metals. Wrong. All transition metals elements are metals. All of them are metals. Remember that. All of them are metals. D. They can be mixed together to form compounds. You know, compound is formed when there's a chemical change, or in other words a chemical reaction, because compounds are a pure substance, and chemical reaction, can it occur between a metal plus metal? No, a metal and a metal cannot react to give a compound, but in one way I can say that a metal and a metal do react, but that story is for oxidation and reduction, कि एक मेटल दूसरे मेटल को ऑक्सीडाइज या रिड्यूस करा सके, वो हो सकता है, but they can't react together and give you a compound. No such chemical reaction can occur between a metal and a metal. So this is wrong. But if they said if they can be mixed together, and if they didn't mention this part to form compounds, then it would have been correct, because we know something as alloys. What are alloys? When different metals are mixed together. An example of that is bronze. Bronze is actually made up of copper and tin and manganese and I think it's and phosphorus, aluminum, and silicon. So there are a lot of metals that are mixed, and metalloids that are mixed in here. So they can form alloys, but alloys are not a homogeneous mixture. They are a heterogeneous mixture, because there's no I don't know if I said that right, but in other words, alloys are not compounds, they're mixtures. Okay, so therefore they're not compounds, no, they're mixtures. There's a physical change, there isn't a chemical change. So yeah, so a metal and a metal cannot react to give compounds, definitely. Okay, so question number 29. 3 different elements react by losing electrons. So it means we're talking about what? Metals, because metals lose electrons and form ions, not non-metals. The ions formed all of the electronic configuration 2,8. Which statement about these elements is correct? They are in the same group. Verify kar lete hain. Let's say I have lithium, sodium, and then potassium. I have their ions. I know lithium is it's 2,1, so it loses 1 electron, gives us 2 electrons are left basically in its ion. Sodium has 11, loses 1, forms 2,8 key electronic configuration. Potassium is 19, loses 1, forms 2,8. So can they possibly be in the same group? I don't think so. Why? Because every time that I go down in the group, one shell number increases. So there's 1 shell, 2 shell, 3 shell. So they can't possibly have, all of them have the configuration 2,8. So A is wrong. Let's look at B. They are in the same group. Let's take the example of period 3. There's sodium, magnesium, aluminum. Sodium is 11, magnesium is 12, and aluminum is 13. If I form their ions, then sodium, when forms its ion, has 10 electrons remaining. 2,8 will be the electronic configuration. Magnesium has 12, loses 2, again has 10 remaining. 2,8. Aluminum has 13, loses 3, has 2,8 again. So can you see that if they're in the same group, in the same period, they can have the same electronic configuration as proven over here. So B is true. Acha, yahan par I would actually like to give a small tip. Whenever they're talking about ions, whenever they're talking about ions, and those ions are metal ions, let me repeat that. If those ions are metal ions, and you have been given the electronic configuration, if in that electronic configuration you see, let's say, 2 shells, which we see over here duplicate, if there are 2 shells, know that the metals are from the 3rd period. Similarly, if the examiner was talking about these ions that are losing electrons, which indicates that they're metal ions, and he says the electronic configuration is 2,8,8. If he says this, if there are 3 shells, 1, 2, 3. If there are 3 shells in the ion of the metal, then that metal belongs to the 4th period. Why? Because metals, when they lose their valence electrons while forming cations, they actually lose their valence shell. So the atom of the cation has one extra shell than its ion. So if the ionic electronic configuration gives you 3 shells, the atom will have 4, and therefore we know that the period number gives us the number of shells, and if you're talking about 4 shells, you're talking about the 4th period. Okay, let's look at just C and D quickly. They are noble gases. Noble gases don't even react. How can they possibly lose electrons? They are transition elements. Transition elements start from 21 to be yeah, they start from 21, and it is what is this? I don't actually remember its name. Scandium, yeah, sorry. Scandium is 21, so its electron configuration is 2883. So if it loses an electron, right, it will give us 288, not 28. So D can't D can't be the answer. Why would I do that? Okay, going on. Metal M is displaced from aqueous M nitrate by copper. Interesting. Which statement about metal M is correct? The chapter of metals most of the time is not clear to students, and therefore they find these questions difficult, even though if you have the right amount of knowledge, they aren't. For example, so we're talking about this metal which was displaced by copper. This means that this metal comes even below copper, because copper is more reactive, and only more reactive metals can displace less reactive metals in their compounds. So I'm going to write the reactivity series here. We have potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. So these are some of the metals in the reactivity series. So if something was displaced by copper, right, then it means that it will come below copper. So M lies somewhere over here. It says which statement about metal M and its compounds is correct? M carbonate is stable when heated. I'll come to this at the end. It's very important. B. M oxide is reduced to M by heating with carbon. So they're saying you have this M oxide and there was carbon, and carbon displaced that M. Can this happen? Carbon lies way above M, as you can see. So because carbon is more reactive than M, it can most certainly displace M in its oxide. So B is correct. C. M reacts with dilute hydrochloric acid to give hydrogen. So can M react with HCl, give us MCl plus hydrogen? No, it can't. Why? Because as you can see, hydrogen, let me use another color, hydrogen lies above M, and therefore this metal, which is less reactive, cannot displace hydrogen in its compound. So C is wrong. D. M reduces zinc oxide to zinc. So they're saying there's M, you react it with zinc oxide, it gives you zinc plus M oxide. Can this happen? Zinc, using another color, zinc lies above M. It can't possibly displace M can't possibly displace zinc in its oxide. So D is wrong. अच्छा, बात अब आती है A पे. A पे एक बड़ा important fact है जो कि I'll tell you ironically, even I didn't knew while I was doing my O levels and perhaps even my A levels. Sometimes teachers teach you this concept in another way. तो वो ये वाला aspect mention करना भूल जाते हैं. This is something that I learned while I started teaching, while I started preparing for these topics. And that is that the stability, let me write it here, the stability of a metal carbonate is actually related to its position in the reactivity series. How? We say all that you need to remember, this is a fact that you must remember, is that the higher, not this, the higher the metal is in the reactivity series, which makes it more reactive it is, more stable will be its carbonate. तो ये बात याद रखिएगा कि रिएक्टिविटी सीरीज में एक मेटल जितना ऊपर होगा, यानी कि वो जितना ज़्यादा रिएक्टिव होगा, उसकी जो ये जो कार्बोनेट है, मेटल कार्बोनेट, वो उतनी स्ट्रांग होगी, उतनी कह लें स्टेबल होगी, उसको डिकम्पोज करना मुश्किल होगा। जैसा कि अगर आप सोडियम कार्बोनेट की बात करें तो ये बहुत स्टेबल है, इसको ब्रेक करना ज़्यादा मुश्किल है, इट्स वेरी स्टेबल, इट डजंट डिकम्पोज ईजली। तो जब हम देखते हैं एम को जो कि इतना नीचे आ रहा है रिएक्टिविटी सीरीज में, जो इतना कम रिएक्टिव है, तो फिर उसकी कार्बोनेट भी कम उसकी कार्बोनेट भी इजीली डिकम्पोज करेगी, कम स्टेबल होगी। बिकॉज आई सेड द हायर इट इज इन द रिएक्टिविटी सीरीज द मोर स्टेबल विल बी इट्स कार्बोनेट। उन्होंने कहा है कि एम कार्बोनेट इज स्टेबल व्हेन हीटेड, रॉन्ग, वो तो बहुत आराम से डिकम्पोज कर जाएगा। सो रिमेंबर दिस फैक्ट, ये वाला जो फैक्ट है ना, ये बड़ा इंपॉर्टेंट है, इसको याद रख लें। अच्छा जी, मूविंग ऑन। 31. Which statement about some of the gases present in air is correct? I'm just going to have a sip of my chai because पढ़ाते वक्त चाय बहुत ज़रूरी होती है, I've come to realize. Okay, which statement about some of the gases present in air is correct? Dry air contains 78% oxygen. देखा नाइट्रोजन निकल गया, 78% नाइट्रोजन होती है, ऑक्सीजन ही होती है। अगर मैं यहाँ पे आप लोगों के लिए कॉम्पोजिशन लिख दूँ तो जो ड्राई एयर की कॉम्पोजिशन होती है, इट इज़ 78% नाइट्रोजन, ठीक है, 21% ऑलमोस्ट ऑक्सीजन, 0.9% ऑलमोस्ट आर्गन, and copper 2 plus copper 2, what is wrong with me, ये 0.04%। ये आपको याद होनी चाहिए, आपका एक बाकायदा टॉपिक है which is called air in O levels। तो ये चक्कर है भाई। तो ड्राई एयर के अंदर 78% नाइट्रोजन होती है, ऑक्सीजन नहीं होती। मीथेन इज प्रोड्यूस्ड बाय इनकम्प्लीट कंबशन ऑफ फॉसिल फ्यूल्स। भाई नो, मीथेन आपकी बनती है, बहुत सारी चीज़ें मीथेन को बनाती हैं, जिस तरह के डिके ऑफ ऑर्गेनिक मैटर, इसमें आपकी काउडंग भी आ जाती है, जब वो डिकम्पोज करेगी तो डिके करेगी सॉरी, तो उससे आपके पास मीथेन बन जाती है। मीथेन इज इवन इमिटेड ड्यूरिंग द प्रोडक्शन एंड ट्रांसपोर्ट ऑफ कोल, नेचुरल गैस एंड ऑयल। बट वो यहाँ पे बात कर एग्जामिनर इनकम्प्लीट कंबशन की। इनकम्प्लीट कंबशन के प्रोडक्ट्स, एक तो पानी तो हमेशा होता ही होता है, दूसरा इट कैन आइदर बी कार्बन मोनोक्साइड और कार्बन, और लेट मी ऐड और, these are the products of incomplete combustion, not methane। मीथेन को आप इनकम्प्लीट कंबशन उसकी कर सकते हो, लाइक मीथेन कैन अंडरगो इनकम्प्लीट कंबशन बट इट कैन नॉट बी प्रोड्यूस्ड, उसके ऊपर तो इनकम्प्लीट कंबशन कराई जाएगी। See, sulfur dioxide is released in volcanoes. It's written in your books. Yes, sulfur dioxide is released by volcanoes. ये तो आपकी किताब में लिखा हुआ है, आपको किताब तो आपको बहुत अच्छी तरीके से आनी चाहिए। D, the noble gases make up about 5%. Nope. देखिए, एक ही noble gas है, there's only one noble gas which is abundant in air, most abundant in air compared to others, that's argon, and that's 0.9%. The others are very very few, they're so small that I don't even want to mention it। You can actually consider all the noble gases making up to almost 0.9% of air, so D is wrong, answer is C। Let's go on। 32, which treatment process is used to disinfect water? जहाँ disinfect आ जाए ना, वो क्लोरीनेशन ही होती है भाई, आंसर इज B। Why? Because chlorine kills bacteria, ठीक है, क्लोरीन बैक्टीरिया को किल करते हैं। और व्हाट इज डिसइंफेक्ट? दैट मीन्स क्लीनिंग, डिस्ट्रॉइंग बैक्टीरिया, माइक्रोब्स। तो क्लोरीनेशन जो होती है, या जो क्लोरीनेशन मीन्स एडिंग क्लोरीन। क्लोरीन किल्स जर्म्स, इट किल्स बैक्टीरिया। विदाउट अ डाउट योर आंसर शुड बी बी। इसमें तो सेकंड थॉट भी नहीं आनी चाहिए, ठीक है। Desalination is removing salt from salt water. That I don't see how you disinfect something through that. Filtration भी नहीं, filtration में आप क्या बैक्टीरिया को बाहर निकाल देंगे? ऐसे नहीं होता, बैक्टीरिया quite small. Iron carbon, again this is not the answer. कार्बन आप डालते हैं, आप एक्चुअली वो चारकोल डालते होते थे उसमें। ये एक एफएससी की थोड़ी सी बात है, लेकिन जब आप फिल्ट्रेशन कर रहे होते हो ना, तो उसमें आप कभी कभी चारकोल ऐड कर देते हो। और चारकोल ऐड करने से क्या करता है, वो कलर एब्जॉर्ब कर लेता है इम्प्योरिटीज़ का। तो उसका यहाँ पे अगेन कोई चक्कर नहीं है, ये मैंने आपको एक्स्ट्रा इन्फॉर्मेशन दे दी है। बट डिसइंफेक्ट करना जहाँ जाए वो भाई क्लोरीन ही होता है। आगे 33, a molecule of compound Q has 3 single CC single bonds and 10 CH bonds only. It has no other bonds. So first of all, this compound is a hydrocarbon because it only has C or H. यहाँ पे एक बात जान लें, a very quick tip. If you have 3 CC single bonds, remember that there will be 4 carbon in the long chain. It's more like number of carbon is 1 plus the number of CC bonds. अच्छा, let me mention number of carbons in the long chain. अगर एग्जामिनर ने आपको लॉन्ग चेन का बताया हो ना, तो फिर अगर वो वैसे ओवरऑल एग्जामिनर कह रहे कि देयर आर 3, as he said here, there are 3 CC single bonds, it means there are 4 carbon atoms. Why do I know that? भाई इधर देखें, 3 CC bonds आप बना कर देख लें। 3 CC bonds आप जब भी बनाएंगे 4 कार्बन एटम्स आएंगे। आप 4 CC bonds बनाएंगे 5 कार्बन एटम्स आएंगे, बिकॉज द बॉन्ड इज फॉर्म बिटवीन 2 एटम्स, राइट? दैट्स व्हाई। बाकी 8 10 है। व्हाट इज दिस? ब्यूटेन। ये ब्यूटेन है आपकी, दिस इज ब्यूटेन, इट्स एल्केन। ठीक है, आगे चलते हैं। ये 10 हो गए। व्हिच स्टेटमेंट अबाउट क्यू इज करेक्ट? ए, इट कैन बी पॉलीमराइज्ड। एल्केन्स जो होती हैं ना, उनके पास सारे सिंगल बॉन्ड्स होते हैं, बड़ी अनरिएक्टिव होती हैं, सो दे डोंट एक्चुअली गेट पॉलीमराइज्ड फॉर दिस लेवल। फॉर ओ लेवल्स जस्ट रिमेंबर एल्केन्स आर नॉट और कैन नॉट बी पॉलीमराइज्ड। अगर आप मेरे से पूछें कि असल में हो सकती हैं, तो जी हो सकती हैं, असल में एल्केन्स को भी पॉलीमराइज किया जा सकता है, बट फॉर ओ लेवल्स रिमेंबर दे कांट बी पॉलीमराइज्ड। अच्छा, बी, इट डीकलराइजेज ब्रोमीन वाटर। वैसे तो ये एल्कीन का टेस्ट होता है, ब्रोमीन वाटर, बट इसमें स्लाइटली सा चांस है कि एल्केन भी कर सकती है, बट दैट वुडंट बी माय फर्स्ट चॉइस। लेट्स लुक एट अदर्स फर्स्ट। इट हैज़ 3 आइसोमर्स। ब्यूटेन के 3 नहीं, इसके 2 आइसोमर्स होते हैं। एक आपका ये लीनियर है, बिल्कुल अनब्रांच्ड स्ट्रक्चर, जिसको हम ब्यूटेन कहते हैं, और दूसरे वाला जो होता है वो आपका ब्रांच होता है, इट्स कॉल्ड मिथाइल प्रोपेन। इसको हम क्या कहते हैं? इसको मिथाइल प्रोपेन कहते हैं, ठीक है। सो नेमिंग आपके सिलेबस में नहीं है फॉर ब्रांच स्ट्रक्चर्स, तो मैंने वो वैसे ही बता दिया, इसका मिथाइल प्रोपेन इसका नाम है। बट देयर 2 आइसोमर्स, वन ऑफ देम इज दिस एंड द सेकंड इज दिस, सो ब्यूटेन डज नॉट हैव 3 आइसोमर्स। इट रिएक्ट्स विद क्लोरीन बाय सब्स्टिट्यूशन। इसमें तो कोई शक वाली बात ही नहीं है, बिकॉज द ओनली 2 रिएक्शंस इन द सिलेबस फॉर एल्केन्स इज आइदर कंबशन, जिसमें कंप्लीट एंड इनकम्प्लीट दोनों आ जाती है, एंड द सेकंड वन इज हैलोजिनेशन, and we know that it's a substitution reaction, so D is correct. CH4 plus Cl2 reacting giving us CH3Cl plus HCl. ये एक एग्जाम्पल है मीथेन की, बड़ी फेमस ही, ठीक है। तो it does react with chlorine by substitution, but if you ask me if this can happen for bromine, it can happen with bromine. B के बारे में मुझे थोड़ी सी स्लाइट सी confusion है, to be honest, and the reason is कि अगर आप एक एल्केन को रिएक्ट करा दो ना ब्रोमीन के साथ, तो इवन इसको ब्रोमिनेशन कहते हैं, इसमें भी रिएक्शन तो हो जाएगा, लेकिन इसमें कंडीशन क्या होती है? इसमें कंडीशन क्या होती है कि यूवी लाइट होनी ज़रूरी है। तो यहाँ पे क्योंकि उसने यूवी लाइट का मेंशन नहीं किया इसलिए आई वाज रिलक्टेंट अबाउट द ऑप्शन बी, क्योंकि ऑप्शन अगर यूवी लाइट होती तो फिर ये ब्रोमिनेशन का रिएक्शन हो सकता था, और अगर ये रिएक्शन हो सकता है तो ब्रोमीन अगर होता तो वो स्लोली स्लोली डी कलराइज भी हो जाता, बट बिकॉज दे हैवंट मेंशन यूवी लाइट आई वुडंट एक्चुअली गो फॉर बी। तो इस वजह से अपने ना सारी ऑप्शंस को एमसीक्यू में चेक किया करें, हो सकता है आपको दो करेक्ट लग रही हो लेकिन किसी ना किसी वजह से एक विल बी more preferred over the other. Okay, moving on. Which organic compound requires the least number of moles? Least की बात करें, moles of oxygen for the complete combustion of 1 mole of the compound. जब भी आपको ये criteria set कर दिया जाए, because in order to have a fair comparison between the number of moles of oxygen required for complete combustion, हम क्या करते हैं कि हम compound को उसका 1 mole ले लेते हैं, हर किसी का एक एक, ताकि वो हम सही तरीके से उनको फेयरनेस के साथ कंपेयर कर सकें। चलिए देखते हैं। C3H7OH, this is propanol reacting with oxygen gives me what? CO2, क्योंकि complete combustion की बात हो रही है तो it will be CO2 plus H2O। अच्छा जी, पहले कार्बन को बैलेंस कर लेते हैं। इधर 3 है तो इधर भी 3 होंगी। यहाँ पर हाइड्रोजन 8 हैं तो इधर 4 हो जाएंगे, तो ये 8 हो गए। यहाँ पर ऑक्सीजन कितने हैं? 6 10। यहाँ पे 1 है ऑलरेडी, तो ये इधर 9/2 लिख देंगे हम, क्योंकि हमें 9 चाहिए। ठीक है, तो एटम्स 9 चाहिए हाइड्रोजन ऑक्सीजन के साइड पे। सो दिस मेक्स इट 4.5। दूसरे वाले को देखते हैं। दिस इज ब्यूटानोइक एसिड, CO2 प्लस H2O। कार्बन इधर कितने हैं? 4, तो इधर आ जाएंगे 4। यहाँ पर हाइड्रोजन कितने हैं? 8, इधर कितने आ जाएंगे? 4। दिस इज 8, दिस इज 12। 2 इधर है तो इधर क्या आ जाएगा? 5, राइट, क्योंकि इधर कितने 8 और 4 कितने बनते हैं? 12 ऑक्सीजन मॉलिक्यूल एटम्स। इधर 2 ऑलरेडी हैं एसिड में, तो पीछे कितने रह गए? 10। 10 हमने लेकर आना है तो 5 इधर हम लगा देंगे। फिर हम आ जाते हैं C3H8 पे। This is propane reacting with oxygen gives us CO2 plus H2O. इधर आ जाएगा 3, इधर आ जाएगा 4, this is 6, this is 10, this will be 5. C4H8. I'm not actually going to dive into कि balancing कैसे होती है या क्या वो, you know, because right now we're doing the past paper practice, I can't really explain everything right now. तो ये 8 है, ये 12 है और ये हो जाएगा 6। बट यहाँ पे मैं बता देती हूँ, द प्रेफरेंस फॉर कम्बशन रिएक्शंस, कम्बशन रिएक्शंस के लिए हमारी प्रेफरेंस ऐसे जाती है, इस CHO। फिर हम कार्बन को बैलेंस करते हैं, फिर हाइड्रोजन को, फिर ऑक्सीजन को। अगर आप इस तरह बैलेंस करोगे तो बहुत ईजी हो जाएगी बैलेंसिंग। सो यू कैन सी दिस रिक्वायर्स 4.5 5 5 6। सो दिस मीन्स कि जो हमारा कंपाउंड ए है उसको लीस्ट अमाउंट ऑफ मोल्स चाहिए। नोट हाउ I kept all the molecules, उनके जो moles हैं I kept them as 1 and I only changed the other moles, or I balanced the equation according to according to having these as 1 mole. अच्छा जी, आगे। Which reaction is an addition reaction? Addition reactions आप पढ़ते हैं under the heading of alkenes, उनके reactions आप पढ़ते हैं और वो सिर्फ 3 आप पढ़ते हैं। There's an addition reaction with hydrogen, with steam and with your halogens like bromine, decolorization of bromine जिसमें आ जाती है। Making ethane and ethene from butane, ये तो क्रैकिंग की एग्जाम्पल है, जब आप एक लार्जर हाइड्रोकार्बन को छोटे हाइड्रोकार्बन में ब्रेक करो। Making ethene and hydrogen for butane, again this is an example of cracking, जब एक बड़ी हाइड्रोकार्बन से हम छोटी बनाते हैं। The manufacture of margarine from a vegetable oil, I don't know अगर आपके टीचर ने ये मेंशन किया होगा, but this margarine is actually formed by what we call as hydrogenation, जो कि basically एक addition reaction ही है alkenes में, जिसमें हम हाइड्रोजन ऐड करते हैं। जिससे हमारे पास लेट्स से अगर ईथीन है, राइट, और उसके अंदर हम हाइड्रोजन ऐड कर देते हैं, हाइड्रोजन गैस, तो हम उससे क्या बना लेते हैं? ईथेन। ये है हाइड्रोजनेशन की एग्जांपल। ठीक है, इसमें हम निकल एज अ कैटलिस्ट यूज़ करते हैं। शायद 250 डिग्री सेल्सियस / 150 डिग्री सेल्सियस, इनमें से कोई टेम्परेचर मेंशन किया होगा आपकी टीचर्स ने। ऐसे में वेरी करते हैं टेम्परेचर्स अकॉर्डिंग टू द एल्कीन बीइंग यूज्ड। लेकिन खैर ये आपके टीचर्स ने शायद मेंशन किए होंगे इनमें से कोई एक। तो ये हाइड्रोजिनेशन है, ये एक एडिशन रिएक्शन है। एंड मार्जरीन जो होती है वो डेफिनेटली इस तरह बनती है। आई जस्ट होप कि आपके टीचर्स ने ये आपको बताया होगा। दिस इज मोर ऑफ अ नॉलेज बेस्ड मेमोरी बेस्ड क्वेश्चन। द रिएक्शन बिटवीन, और अगर आपको नहीं भी आता ना ये, तो आप डी ऑप्शन को पहले एक्सप्लोर कर लो। द रिएक्शन बिटवीन इथीन एंड ऑक्सीजन गिविंग कार्बन डाइऑक्साइड एंड वाटर, ये तो कंबशन की एग्जांपल है। सो इवन थ्रू एलिमिनेशन यू कैन गेट टू द आंसर सी। मूविंग ऑन 36. Two equations involve ethanol are shown. Which row is correct? So देखो, we know carboxylic acids are formed through the oxidation of alcohols. So we have ethanol. Ethanol है तो ethanoic acid बनेगा. If there's propanol, there will be propanoic acid. If there's butanol, there will be butanoic acid. So the number of carbon atoms remains the same, and therefore जो root word है वो भी same ही रहता है. इसकी मैं बेशक लिख देती हूँ equation. Ethanol is C2H5OH. H means that there are two carbon atoms. So carbon atoms दो इधर ही रहेंगे, but क्योंकि acid के अंदर एक carbon atom comes in the carboxylic acid group, functional group, so therefore हम उसको ऐसे लिखते हैं, and this remains with remaining product as water. ऑक्सीडेशन का तो उसका कहा है कि मोलिकुलर फार्मूला ऑफ कार्बोक्सिलिक एसिड 1 CH3COOH। तो ये तो खैर ये बच्चे क्योंकि कंफ्यूज हो जाते हैं, दे थिंक सो एथेनोइक एसिड 2 कार्बन एटम्स, दे फॉरगेट दैट देयर इज अ कार्बन एटम इन द एथेनोइक इन द कार्बोक्सिलिक एसिड ग्रुप एज वेल, सो इट कांट बी 2 and B and D because that's propanoic acid. It's either A or B. A catalyst is needed. Well, you don't need a catalyst for oxidation, but you do need a catalyst for fermentation process. Remember कि fermentation के लिए you use yeast. Yeast के अंदर एक enzyme होता है zymase. Zymase is actually the it's a enzyme. Enzyme are what? They're biological catalyst. So same thing. They're called biological catalyst. So zymase is required here. So 2 does require a catalyst. So the answer is C. Moving on. What is the empirical formula of ethanoic acid? This is kind of simple. Ethanoic acid abhi humne baat ki CH3COOH. If I combine the number of carbon atoms 2, hydrogen 4, oxygen 2. Empirical formula is the simplest ratio between the atoms of different elements in a compound. So yahan pe they're all divisible by 2. So I can basically make this CH2O. So answer is A. Moving on. What structure represents propyl methanoate? So this is an example of an ester. In the I don't remember if I mentioned this before, but whenever something ends with anoate, we are basically talking about the anion of a carboxylic acid. Remember that. What do I mean? This is a methanoate. What does methanoic acid looks like? Meth means one carbon atom, so this is what methanoic acid looks like. So when this basically dissociates, this H positive ion is removed and you're left with HCOO negative. This is an anion because it has a negative charge overall, right? This is called as the methanoate ion. So remember, when you have this root word and at the end you have anoate, remember it's an anion of the carboxylic acid. ठीक है, तो ये अगर आप बात याद रख लो ना कि कार्बोक्सिलिक एसिड का होता है वो जो आपका जो बेसिकली एनोएट से एंड करता है टर्म, वो बेसिकली कार्बोक्सिलिक एसिड की एनाइन है, उससे यू कैन इजीली नो, क्योंकि यू गाइस गेट कंफ्यूज कि प्रोपाइल रिप्रेजेंट्स द एसिड और द अल्कोहल एंड मेथानोएट रिप्रेजेंट्स द एसिड और द अल्कोहल. सो इफ यू रिमेंबर दैट मेथानोएट और एनीथिंग दैट एंड्स विद एनोएट इज एक्चुअली द एनाइन ऑफ द कार्बोक्सिलिक एसिड, then you would easily know that methanoate is referring to the carboxylic acid. So we're referring to HCOOH, and therefore if this is the acid part in the naming, then this is the alcohol part, and this is propyl. Prop means 3, so this is a propanol. So propanol and methanoic acid combined and gave us propyl methanoate. Acha, so which of the structures is this? Remember that wherever you see the C double O part, ये जो आपको C double O part नजर आ रहा है ना, ये this always belongs to the acid. This one, the C double O part in C, not O. Again, this part over here, it is this part. So this is the acid part. Remember, the C double O part is the acid part, and the O part where you have the O, CO, this is the alcohol part, alcohol part, alcohol part. Okay. If you get to differentiate them, then you can clearly see. I'm looking for what? Propanol. So propanol is where? This is what? Methanol. Okay, this is not even methanol actually. This is just a OH group, because even methanol is CH3OH. So I don't see a carbon in it. So this is just a hydroxyl group. Over here I see propanol, 1, 2, 3 carbons, and then O. So this is propanol. This is ethanol, 2 carbon atoms, and this is one, so methanol, and this is just a hydroxyl. So the answer is B. If I look at methanoate, I need what? HCOO. So HCO. This is 1, 2, 3 carbon atoms, actually 4 carbon atoms, so that's butanoic. This will be butanoate ion if I separate it. These are 2 carbon atoms, ethanoate, or you could say ethanoic acid, coming from ethanoic acid. And this is 3, so it's propanoic acid. A quick tip over here. Talking about an acid, let's say this is acid, and let's say this is actually I'll make that again. Wait. Let's say this is my acid and this is my alcohol. What happens is that the OH is removed from the acid and H is removed from the alcohol, and this results in this, and this C double O is called the ester bond. Okay, so anything that has C double O is an ester. Okay, remember that. तो यहाँ पे आपको सी डबल ओ नज़र आ रहा है, यहाँ पर आपको सी डबल ओ नज़र आ रहा है, यहाँ पर आपको किधर है सी डबल ओ नज़र आ रहा है, यहाँ पर आपको सी डबल ओ नज़र आ रहा है. So this means they are esters, and we know that when acid and alcohol react together they form esters. So in naming, one more thing, in naming we always write the alcohol first and the acid later, but while drawing we make the acid first and then the alcohol. That's what we do usually. Usually we do that. लेकिन यहाँ पे सारे opposite लिखे हुए हैं, I've noticed. Okay, let's move on. Monomer Z is used to make polychloroethene. What is the monomer Z? Do you even if I don't look over here, this is chloroethene. What does chloroethene look like? CC H H H Cl. This is what chloroethene looks like, if you know. So I can actually, without looking here, I can dive to the answer of C. But even if I don't know that, how can you see this? You have this and also let me mention this. This is a addition polymerization happening here, because we were making this from an alkene. Okay, so how did I know it's this? Because look at the structure. What do you see being repeated? If I were to divide this, this is 1 unit, this is 1 unit, this is 1 unit. Remember, in addition polymerization, the monomer is always 1. It's the same monomer being repeated again and again. So if you see the same structure, then a same structure, make divisions for yourself. And if in each division you see the same formula, the same the same representation of atoms, then it means that you have found the monomer. And because what happens in addition polymerization is that your alkenes lose their double bond, right, and they form these chains. So remember to add the double bond. Don't go for A, please. This is an alkane. Alkanes, as I said, don't form polymers. 40. Tyrolene, a man-made fiber is used to make clothing. Which row describes tyrolene? Tyrolene is an example of polyester. Polyester. I just said recently, where do we get the ester from? We name this ester because it has a double bond. Um, let me make this neatly. Uh-oh. Why do we name something as an ester? Because of the ester bond. And where does this come from? Acid plus alcohol. So this means if toluene is a polyester, if it is an ester, then it also will be made from an acid and an alcohol. So it can't be an alkene. Type of polymerization. Well, it isn't an addition polymerization because I said in addition you have only one monomer. Over here you have an acid and you have an alcohol, which are together forming the polyester. So it's condensation. And remember, in condensation, there's always an elimination of some small molecule, but in addition, there's no elimination of a small molecule. Just for the sake of drawing it here, I'll make it. आपका असल में होता क्या है? आपके पास there's this molecule, and then let's say you have this molecule. OH यहाँ से जाता है, यहाँ से जाता है. So what happens? You eliminate a water molecule. And you're left with this, and this is called the ester bond, right? So there's elimination of water here, so therefore it's condensation. Addition with there's no elimination of small molecules. So that's it for today, guys, for today's session. I hope you found it helpful. We have successfully completed major 2019 paper 1-2, which is amazing. If you like this video, give it a thumbs up. If you want me to make future videos, on some specific past papers, do write it below. Other than that, visit our Instagram page for any information about ongoing sessions, because we do have a past paper session, P1 past paper session, that is starting from the 4th of August. So for any updated information, you need to visit the Instagram page. The link is in the description box. I don't know if I repeated that, but well and good. See you next time. Till then, Khuda Hafiz.